My limits review for you.
Okay.
And may I come take the test tomorrow in advisory?
Yep, that'd be great.
The high school is Monday, February 13th, 2022. Will you please join me for a minute of silence?
Hey, I'm gonna be out of school on Wednesday and Friday. Should I come in on Tuesday advisory to take a quiz or?
Yeah, that'd be best.
Alright, thank you.
Thank you very much. Will you please stand as you are able for the pledge? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you very much. Have a great day.
All right, so last class, it's been a while since I've seen y'all, since last week was the B week, but last class we had our limits test and we are moving on from that, so no more limit stuff. And then the next real big topic that we're aiming for is we need to review what you learned about logarithms in Algebra 2 and go quite a bit deeper. Logarithms are super important for college algebra and calculus. But before we can really dive into logarithms and make sure that you have a good understanding of that, we need to spend a day or two on exponential functions. And then before we should do that, we should spend a day on inverse functions. So that is what we are doing here. And the thought process behind that is exponential functions and logarithmic functions are inverses of each other. So if we review what it means to be an inverse function for a class period, and then we spend a class or two on exponential functions, you automatically know a little bit about logarithms just because they are the inverse functions. So meant to make that a little bit easier. So our lesson today is pretty short. We're going to go over the 1.9 notes. So I'm going to review and all the stuff you need to know about inverse functions. When we came back from winter break, I had said something that hasn't really applied thus far this semester, but most of this semester is going to be algebra review. So we did law of sines and law of cosines, got that out of the way to hopefully help you with the ACT. We spent a few weeks on limits, tried to spread that out so that it wasn't too much any one given day. But the most of the rest of the year is algebra review. So you're going to see that in today, that most of this should sound familiar to you. But of course, you may have forgotten some of it since last year, or there may have been some of these things that your algebra teacher didn't make you learn, but they're things that you need to know. So for most people, I think this will be pretty easy. But again, if you have forgotten all of it, or you just really didn't learn it last year, then, oops, wrong one. Then you'll have to put in a little bit more effort than everybody else. Okay, so what I'd like to do here is go over the notes to just give you kind of a refresher of all that stuff, and then I'm going to give you 10 or 15 minutes to work on the second handout and use it kind of as a practice quiz, just to see how much of this sticks and add it to what you already knew before I said anything about it, and then that should help highlight what you need to review for the quiz next class. Okay, so first up, how to find an inverse function. You're going to switch or swap the input, which is usually x, with the output, which is usually y. So we did some inverse stuff last semester too. It was inverse trig stuff, and you don't really need to remember any of that for this, but we didn't do x and y's with the trig stuff. We did angle with ratio. Usually you plug in an angle and get a ratio as an output, but if we did inverse functions, we switched those and we inputted a ratio and outputted an angle. Second step is to solve for y and then rename him to this. This is the notation for inverse function. Just like inverse sine, inverse cosine, inverse tangent all have that little -1 looking exponent. It's not really a -1 exponent, by the way. It's just that's what the notation looks like. But same thing. If f is the function, f with this little symbol is his inverse. Okay, so one example of that, if I wanted to find the inverse of this, I would switch the input and the output, solve for y, and then here's why you really need to rename it this way, because f of x is the same thing as y. Y can't be 2x plus 1 and x minus 1 over 2. Those are not equal statements, so we can't say y is equal to both of them. So instead of saying y equals here, we're going to say the inverse is this. So switch x and y, solve for y. That's how you get the inverse. Okay, we'd also like to know how to prove that two functions are inverses, and the only way to prove that for sure is algebraically, which I'm about to show you. And then we'll talk about how to be fairly sure that they're inverses of each other graphically. So the only way to prove or know if they are function or verify that two functions are inverses of each other, let's say we're talking about f and g, you would have to plug g into f and then plug f into g, so composition of functions. And if both of those directions simplify to x, then we have proven that they are actually inverse functions of each other. Plug each one into the other one and simplify, show that they simplify to x. That's the algebraic way to verify. So we'll take these two that we know are inverses of each other, because they're the same two that we worked with in the first few questions. But if you're asked to prove or verify, one time you should plug all of this stuff into this one. And then another time you should plug all of this into this one. Everywhere there's an x, you're plugging in the other one. And then simplify. Times 2 divided by 2 cancels, plus 1 minus 1 cancels, plus 1 minus 1 cancels, times 2 divided by 2 cancels. If you can show both directions simplify to x, then that is how you prove it. And if they don't simplify to x, then they're not really inverses of each other. So again, not too much like arithmetic or real work here. Undoing those steps are very easy, but you just have to know what the process is to prove them. Okay, I will give you guys a chance to speak up and ask questions as we finish the last part. So let's move on. So that's how we do it algebraically, and it works 100% of the time. It's a full proof. If that works, then we know 100% sure. 99% sure you can do it graphically. And to do it graphically, you should graph both functions. And if they are really inverses of each other, there will be a line of symmetry at y equals x. So if you know what you're looking for, you can usually just eyeball the graphs and know if they're inverses or not. This is not good enough for a proof because it may look like there's a line of symmetry at y equals x and one of them could just be a tiny bit off. But this is usually good enough for like the ACT. So let's say on the ACT, they gave you this function and they said find its inverse function. And either you think this is going to be quicker or you just don't remember how to find inverse functions. What you could do is you could go to your calculator, have it graph this. Y-intercept of 1, slope of 2. You could have it graph this on the same line. And I'm going to split this fraction apart to help me see the y-intercept and the slope. And then I usually just have it graph even a third graph, y equals x, which is the line where every point x and y are equal. And if y equals x is cutting your graph in half, then it's a line of symmetry. If I was to flip this red line over it, it would land on the black line. If I flipped the black line over it, it would land on the red line. Or just cut your overall graph in half. Again, this doesn't really work well enough for a proof because this could look like these are reflections and this one could just be, just a tiny bit off. But on the ACT, if this was choice A and you graphed them and it looks like that have symmetry, then it's pretty safe to pick that and move on. And if it doesn't look like it has that symmetry, then try choice B. And if it doesn't look like it has that symmetry, try choice C. And again, it's just an option if you think that's faster than what we did on the front. Okay, and then the last little group here, we need to remember that if you pass the vertical line test, that's how you know that a relation is a function. But if it passes the horizontal line test, it means a function's inverse is a function. And again, you don't have to remember all of this from last semester, but with the trig functions, if we took the regular 6 trig graphs, they were functions because they passed the vertical line test, but they did not pass the horizontal line test. So we limited the domain, which means the inverse functions had a limited range. And if you remember, we had to memorize those 6 ranges, and we had to make sure our answers landed in those ranges. So that's why, because we wanted those inverses to be a function. Now, you need to squeeze this one in here, but there is a term that we'll throw at you, and I've seen on the ACT before. 1-to-1 just means it passes the vertical line test and the horizontal line test. If it passes both, it's called a 1-to-1 function. Okay, and then finally, let's talk about how a point on a function and the inverse relates to each other, and one thing that kind of happens because of this. So let's just hypothetically pretend like we've got a few points for a function, maybe 0, 0, I don't know, 1, 3, and -2, -4. I don't know. maybe not the best points. But we will expect you to be able to tell us a few points on the inverse. So since inverse just means you're swapping x and y, you switch 0, 0, it's still going to stay 0, 0. But 1, 3 would become 3, 1. And negative 2, negative 4 would become negative 4, negative 2. XY becomes YX. Switch X and Y, switch X and Y. That's all you have to do to get a point from a function to his inverse. Now, I went ahead and graphed these as well because I just wanted to show you one more time. If two things are really inverses of each other, y equals x is a line of symmetry. It cuts your overall graph in half. You could flip either one of those over and it would land on the other one. Now, it doesn't look perfect because my graph is a rough sketch, but if I made it a little more to scale, then that would be better. Okay, and then finally, because of this, there's one more thing that happens that I need to make sure that you remember. And that is that the domain and range of a function become the range and domain of the inverse. Possible x's become possible y's become possible x's. That's one effect of switching x and y. And I like you to see it with these points here because I think it shows you, or it's a little bit easier to see. But for the function here was a domain, the x values the graph hit. So the domain of the function became the range of the inverse. X values became y values. And the range of the function became the domain of the inverse. So make sure you understand that. Domain becomes range, range becomes domain. Okay, so of the inverse specific stuff, this is the stuff that you need to remember or relearn or fill in the gaps from last year, wherever you stand on that. So what I'd like you, I promised I'd give you a chance to ask questions. So anything on this that I went through too quickly, or anything that you'd like to ask from just a notes page? Okay, then I'm going to set a 15-minute timer, and I would like you to try this worksheet just to see from that small reminder how much of this you actually know and what you need to study and how much you need to study. So 15 minutes from now, we'll go over it, help you fill in some gaps and identify what it is you need to do. And that will be pretty much it for today. There is one other thing I just want to go ahead and say before I forget, since I haven't seen you guys much lately because last week was a B week. There is a math competition coming up called the ACTM. And if you'd like to sign up for it, I need you to be aware that there is a $5 fee that goes along with that. So that's not the high school trying to make money off of you. That's what the university charges. It is a math test that is Saturday, March 3rd, March 4th. So it is a Saturday morning. So you do have to be, fairly dedicated to want to do it. But I do think Mu Alpha Theta is maybe given some hours or given an hour or something this year. So if you're in Mu Alpha Theta, you've probably already heard about it from that. I'm bringing it up because if you want to sign up, you have to tell me that you're interested, and I have to have your $5 by the end of this week. There's a process where I have to get the money to someone on campus, and then they change it to a check, and then that check gets sent to the university. So if you want to participate, that's great. But just make sure I have your money, because if you miss that window, it'll be out of my hands and there's nothing I can do. So, okay, so go ahead and keep going, please. In 15 minutes from now, we'll go over it and grade it and see how you did. 5 more minutes. Okay, so finished or not, let's go ahead and check your work and see what it is, which questions you need to mark to review before class next time. So question 1 gives us a ton of points, and then it says write the ordered pair for the inverse. So all you had to do was switch x and y. Not sure why there was so many points, but I guess that doesn't make it any harder. But xy on a function becomes yx on the inverse. Okay, question 2 asks us to verify that these two are actually inverses of each other. And they gave us a couple tips here that you may not get on the quiz. First off, it's telling you to use composition of functions, which is what these are saying. But you should not need to be told that to know how to prove it. You should have plugged this one in to that one, distributed your 4, and undo plus with the minus, and you do have to go both ways, and plug this one into that one, distribute the 1/4, undo the -3 with the +3, and show that both directions simplified to x. But you may not get this clue, or this clue on the quiz. That's the only way to prove it, is algebraically. Okay, question 3, there could be many correct answers here. So what has to be true about part A? To be a function, it has to pass the vertical line test. So whatever answer you came up with, that has to be true. But then not to be one-to-one means that it has to fail the horizontal line test. So a function like this, that passes the vertical line test, but it also passes the horizontal line test. That's not good enough. I would just do something like x squared. That passes the vertical line test, which makes it a function, but he fails the horizontal line test, so he's not one-to-one. So you don't have to have the same answer as me, but it's got to meet those requirements. Whereas part B is supposed to be a function. So your answer needs to pass the vertical line test. So I'm just going to see if the last answer will work again. But this one is supposed to be one-to-one. So he also has to pass the horizontal line test. So even though this worked for part A, this would not work for part B. He does not pass the horizontal line test. So any function, again, try not to make it too complicated. Go with something easy. Here's a function that passes both, so that would be fine. But many correct answers there. Try to pick out something easy for yourself, though. You don't have to complicate it. Okay, on question 4, it wants us to find the inverse of this. And they gave us the steps, but the steps may not be provided for you on the quiz. So the first thing we did in our notes was do this. So switch x and y, and then solve for y. But don't leave it y equals, because y can't be x squared minus 1 and the square root of x plus 1. Those are two different values, so they can't be equal to the same thing. So make sure you called it that with a little -1 exponent notation. Looking exponent notation. Not really. We okay with that? Okay. This, I didn't put together this worksheet. This one's been around for a long time, but I don't really know why they wanted you to make this table, but I guess if we plug in 0 here, you get -1, plug in 1, you get 0, plug in 2, you get 3. So I'm not really sure what the reference is there and how that's supposed to help. But I think this is one of the harder questions. The domain of the inverse. But luckily, we could work this one a couple different ways. So I'm going to show you both so that you've got some options, or in fact, it might be best to just do both on the quiz to make sure you get the same answer. So first off, remember that the function's domain and range is the same as the inverse's range and domain. Domain becomes range, range becomes domain. The domain of this guy was right here. He had a restricted domain of 0 to infinity. So that means the range of the inverse would be 0 to infinity. So that would be the easier part of this to answer. If this had asked range instead of domain, our answer would be 0 to infinity. But to get the domain of this is the same as the range of this, and there's really not a good algebraic way to get range. Really, you should think about what the graph looks like. It looks like x squared shifted down 1. So the y values that this graph hits are from -1 to infinity. And his range is the same as this guy's domain, which is what this was asking for. So that's option number 1 to come out with that. Option number 2 is you could say, well, here's the inverse. I could think about this function and what his domain is. So if you graph this, which you would need to know what the square root of x looks like, and to know that this +1 is going to shift it left 1. But then you can just look at your graph and see that it goes from -1 to infinity. So, two options that are both equally fine, but sometimes one might be easier than the others, depending on the function. Okay, question 5 is just like question 1. I don't know why. I mean, I guess it's phrased just a touch differently, but xy becomes yx. Switch x and y, and your function points become your inverse function points. I'm going to skip question 6 and save it for last, because to me this is probably the most missed one if we actually graded this. So number 7, to be a function, it has to pass the vertical line test. If it also passes the horizontal line test, then its inverse is a function. So he has an inverse, but the inverse may not be a function unless it passes the horizontal line test. And if it passes both, we refer to it as 1-to-1. 1-to-1 is passes vertical and horizontal. Okay, I would say probably the most common answer for number 6 is students would like to pick not possible here, but this one is possible. So we need to think about what is required here and then see why, if you said not possible, if it was just because you may have given up a little bit too quickly. But first off, it's got to be a function. So our final answer needs to pass the vertical line test. He does not have an inverse function, which means my final answer needs to fail the horizontal line test. And then the part that makes this a little kind of guess and checky is this odd. You need to remember the difference between even and odd functions. So odd is when it's symmetric to the origin, like x cubed. If you turn your graph upside down and it looks the same, that's a characteristic of an odd function. Whereas an even function, like x squared, is symmetric to the y-axis. But this question wanted an odd function. So, unfortunately, what you have to do on a question like this is just pick something. I'm going to pick x cubed, and then see if that meets all the requirements, and if not, try to make some adjustments. So x cubed does pass the vertical line test. Unfortunately, he also passes the horizontal line test, so this doesn't work as the final answer. But I've got to keep something that's symmetric to the origin, still passes the vertical line test, but I need to mess it up to where it does not pass the horizontal line test. So this is not the only option, but what you can do is you can make this dip down a little bit, and then as long as you keep the symmetry, it's a function. His inverse is not a function, and he's odd because it has the right type of symmetry. That graph would look the same completely upside down, symmetric to the origin. So more often than not, students kind of give up a little bit too quickly on that one, but there are odd functions that meet those requirements. Okay, so this is not exactly what the quiz is going to look like, but a pretty rough idea should help you see which things you need to review. So while all of this is fresh in your head, I would highly suggest you circle those questions. And before I turn the screen off here, if there's any of these you want me to talk about again, or if you have specific questions, now would be a good time. Anything y'all want to ask? Okay. Well, if you change your mind, you've still got about 35 minutes, so still plenty of time. But again, we're not going too in-depth on this, but this is really to help you so that when we do exponential functions next, I can tell you that inverse functions and logarithmic functions are inverses of each other. So if you know what an exponential function looks like on a graph, that's going to help us know what a logarithmic function is going to look like on the graph. If we know some points on an exponential function, we should technically know some points on a logarithmic function because they're just inverses. So, seems kind of out of place, but that is our thinking on that. So make sure that you know what it is you need to review and study. I am going to ask you to turn in number 80 for some points, and that is already open in Google Classroom, so if you want to just get that over with, you can, but otherwise I'll ask for it before we start the quiz on Wednesday. This is a week, so I will see you guys on Friday this week. However, next Monday is a no school day, so. But if you do find something I can help with, please let me know. There's plenty of class time if you need help.
I found the practice. It was stapled to my notes.
Okay. Here you go. Take it right back. I'll put it right in.
Thank you.
Yep.
Is there any way I could take the quiz today in class?
You won't have time to do the whole thing. You could do one page of it if you wanted to, but it's too long to do the whole thing.
Okay, never mind. Thank you.
Okay. Oh, I'm sorry. You're talking about this quiz?
Yes.
Yeah, I don't have it printed off yet. I'm sorry. I thought you were talking about the last test.
Okay.